We are going to continue this review for topic 13 through 15, starting with number 10. Here we have an exponential growth model. We have some town that's doubling in size every 4 years, or 34 years, and the current population is 500. What will the population be in 102 years? Okay, something that's missing here that we see in problem number 12 is the word compounded, and so we are doubling every certain number of years, and so, but it's not compounded continuously, or it's not compounded monthly, something like that, like we deal with some of our interest equations. And so we can use this basic formula, y equals a times b to the x, where a is our starting amount. So how much do we start with? We start with 500 people, so currently 500. And then we know that we are doubling in size. So what do I write as my multiplier if we're doubling in size? That would be a 2. Normally I would say, if it said we're grow by 7%, something like that, I would say that your b value is going to equal 1 plus that rate divided by 100. Because that's what percent means, is that it's out of 100. So for this example, that would be 1.07. That would be your growth rate. For this one, we have a b value of 2 because we have the original 500, and then we double it, so we have 500 more. That's one full amount of 500 plus another full amount of 500. I use this example if we have one Mr. Hines, and then we double him. Now we have 2 Mr. Hineses. Okay, so b is 2, and we need to know what the exponent is. Well, the exponent is not a number of years, it's the number of times we go by this multiplier, the number of times we double. So how many times do we double in 102 years? Well, the first double would happen at 34 years. The second double would happen 34 years later at 68. The third double would happen at 102 years. Okay, so you could do like a little linear table here where we're adding 34 every time, or you could just do 102 total years divided by 34 years per double, and you get 3 doubles. So that's what we put up here. So y is equal to 2 to the third power. 2 to the third power is 8, so we're going to end up with 4,000 people in 102 years. Which, you know, that takes a long time, but now it's a booming town. So, number 12, go talk about Ella. Ella's just opened a savings account. She's a high roller who deposited $500 as her principal. $500, good for Ella. She earns 14% interest, also good for Ella. So interest rate is 14%. And I'm going to go ahead and convert that to a decimal. That would be 0.14. And then the big statement here for us, because it helps us know what equation to use, is that it's compounded continuously. So that means we're going to use a equals p times e to the rt, where e is the exponential. It's a number, 2.71281828, I think, something like that. So we're going to plug in what we know to find out whatever they ask us about. How long will it take for her account to reach $875? So the goal for her is to reach $875.34. But right now, she currently has $500, growing at a rate of 0.14 times time. Big difference for the a equals pe to the rt equation is for the growth rate, we just put in the percentage. We don't put in 1.14 to show that she keeps the original amount. We just put in the rate as a decimal, the interest rate as a decimal. And so what do we need to do now? We need to divide by 500. And then we have just a simple exponential equation. 875.34 over 500 is equal to e to the 0.14t. And now we can rewrite that as a logarithm. Okay, so remember the base is always the base. So log base e. And then the other two will trade place is over 500. And so remember the answer to a log is an exponent. So what's our exponent? This is our exponent. So in our logarithmic equation, our answer to the log should be the exponent, 0.14t. So we'll get a number for that. But before we do, I want to make a statement that log base e it's a natural log. It has its own specific. If I type in a log on my calculator without a different base, it's going to be log base 10. If I type in natural log, it's just understood that the base is e. Yeah. And that's equal to 0.14t. So whatever I get for my log here, I am then going to divide it by 0.14. Sorry, I know I'm running out of room here. Let's go to the calculator. And this will be it for this video. But we're going to do the natural log of 875.34. Yeah. 875.34 divided by 500, and then we're going to divide that by 0.14. And it gets right at 4. So just a little more than 4. I feel pretty comfortable rounding that and saying t is about 4 years. So not bad, but also not great. Keep working on it, Ella, and we will keep working on the review in another video.